This is Olu for Team Mount Olympus. It's been a difficult one making this video because videoing what you're doing and making sure it works is a big problem in a sense. But again, I'm gonna launch this to make sure that you see it compiles. It already says it compiles, but I'm gonna run it again, and that comes up because I ended up having this files open by error. I should have defaulted to go to download, but that's my error. And now I'm gonna go back to the Sonar itself and show you stuff white sweeps. See the Sonar moving, and this item as the accelerometer sweeps through, it picks up objects at a certain distance, and that should be more than suffice for this assignment. It's supposed to pick up items within a certain distance and then to sweep back again, and the radar's moving and the accelerometer is picking up items at the certain distance. If the distance does increase, it picks them up. If you look at, hopefully you can see the items moving as the radar is rotating using its motor mounted on top of it. The accelerometer is picking up objects. At this point, it's picking up an even object. It could be my phone recording right now, but I'll use my hand, and you see it changes a little bit, and I think this should be more than suffice for this part of the assignment. Again, if it picks up, if I increase the distance, it should pick up items within that distance and should pick them up randomly, and this is exactly what it's doing according to assignment. It's supposed to integrate our graphical sweep display to output position of objects, which it is doing right now from a radar platform as it rotates to a 180 degrees, which the radar is rotating to a 180 degrees on the motor rotor, and observed objects should appear on the display, which they appear as dots, as you can see. Evenly, when I stood in front of a glass, it was pretty even. Right now, it's facing a wall at my house, so it's kind of even too, like an even surface. And said observed objects should appear on display at a proportional distance, and as you can see, they're being observed at a proportional distance from the center, corresponding to the distance of the objects from the radar station. And I believe that's it. I'm showing visually what we were reported on the console for assignment number 1, just like a radar station should be expected to do. On assignment number 2 wiki page, I'll describe how our assigned tasks to priority levels. That is, what's the priority level of each task. For example, I'm gonna do the priority level now so you can see. If you look at this is my finger and stop. It stops the sweep. I can go back again, and the sweep starts over again, and I can press button and hold it and stops, and I can press again, it stops, and that explains the scheduling. And I'll continue there, rotating again. I think this should be suffice. This should suffice for this part of the assignment. So as I've shown, the objects again, you can see it's picking up further objects. Maybe I think my phone moved a bit further now. It's not looking at just the wall anymore. And again, this was the code. And this is a part of the code where I set up the angles or the range at which it sweeps. Also, there were a couple things that were a problem. Knowing the heights of each circle, like embedded in each other, was slightly a problem to modify it right. And also, my wirings were a bit off initially, but they're okay now. Let me see. So we use the same configuration that we used before for the pin in and pin out. Pin name for the data and clock. And also, I had to change some things around to maximize the use of the embed device. I tried using some other methods, and then the speed of my motor was at 2000. I think that's average enough. It's not going too fast. And this is the angle of declination I was talking about for San Diego. The angle of declination is 11.33. As I move forward, I think I'll probably include that and embed that into my system. But for now, I'm going to use a generic angle of declination of 0.00. And also the radar maximum range was at 1000. Also, the pi, depending on which pi you use, things change around a little bit. And that's pretty much it. Thank you for watching, and hopefully I didn't bore you to death. Going back to the radar, still moving, rotating, and items found at a certain distance, it picks them up. See, as I move my hand, see my hand? So my hand that farther away, look at that multiple rotation messes up a little bit. See it? So it picks up my hand, picks up some other things, and that is it. Thank you very much for watching. And a piece of paper, that does another thing. It picks up, so it works. Thank you. Bye.